Alright, we'll be applying everything we've gone over so far. A couple of ground rules here. We're rounding to the nearest angle, and we're rounding to the hundredths. So only going two decimal places. So yeah. Anyway, the hardest thing I think is drawing pictures for all these. And then we can do it from there because we just got triangles. So if we have a lighthouse, we'll say this is our lighthouse. And we got our boat, so in the boat, chilling in the water somewhere. This is overhead view, overhead view. Alright. In the water. Alright, so this distance says it's 2,400 meters away. Alright, then my boat's going to go some more. And
what is the date today?
Behind it every day.
Today is September 17th. My birthday.
It's your birthday.
Yes.
Alright, so now my boat, it says, is 2,650 away. So maybe that could be my hypotenuse.
What is that after the 24 on the bottom?
That?
Oh,
That 2 0? Sorry, not 6. Like 2 much.
Is there a house in here?
It's my boat.
It's a boat.
Boat?
Read the problem. It's a boat. Clearly.
That's what we're thinking. Oh, my birds.
Yeah, it's from a boat. No, they're waves. Come on now. Come on. All right. Either way, we got a triangle now. Boom, boom, boom. Got a triangle. By what angle did the ship's bearing from the lighthouse change? So we're talking about this angle right here. So how am I going to figure out what angle that is? Sakato. So when you say Sakato, what do you mean?
We have a good wait. Oh, Pythagoras. Yeah.
All right, that's B, right? I want to know A, the angle first.
Sine.
Sine is over hypotenuse.
Well, you know what side?
Cosine.
Moon.
Cosine of theta. Cosine of theta is cosine of what again? What's cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So adjacent 2,400 over 2,650. Now yesterday we talked about if you don't have an angle and you're trying to find the angle, what trig function thing do we do?
Negative.
So we do the inverse, right? We do the second cosine, the negative one thing. So in my calculators, this is what I'm doing. I hit second cosine, and then punch in 2,400 over 2,650. That equals your theta.
25.
Be sure your calculator's in degrees. And I've heard people say 25.
25.
Yeah, well, we're running the nearest angle here on this one. So A is 25 degrees, that's A.
What did he say?
A B says, right, how far the ship went. So that's talking about this value, right? So how do I do B? Pythagorean theorem, right? 2,650 squared minus 2,400 squared. Yeah, and then I need to take the square root, right? So I'm doing 2,650 squared minus 2,400 squared. Take the square root of that. 1,123.61. 1,100 squared what? 23.61. And that's meters, right? Boom. That's B. Questions about what we just did? About either A or B. How would we do the picture? I know it doesn't look like a ship, but you know.
Also,
I guess if you want to fix, you do that.
I have a question.
Yes, ma'am.
Did you already square those numbers? Or
No.
did it show it?
No, it's not.
Did you just subtracted it?
But you squared it, so that's this distance squared minus this distance, gives me this squared. So you need to take the square root of that.
But you did.
So in my calculator, I did 2650
Oh, you
squared
did do that. Oh,
minus
that's what I
2400
was
squared.
saying. I was asking if you just did it without showing it.
All right, any other questions? All right, number 2. First on the edge of the canal, there's a lamp post. Don't have to draw a map this time, there you go. Good picture of that. Elevation is 12 degrees, depression 7. So that's why we got 12 going up from parallel with the horizon. So that's elevation, that's depression. So this dude's 152 feet tall, or from his eye level, I should say. So is there anything else I can use here?
Oh, you can put the 152 on the post.
On this side right here? So up to this point is 152 centimeters as well. Now let's see. A says to find the width, bless you, of the canal. So I'm trying to figure out how far the dude is from land. So I use tangent.
Yeah. 70.
So tangent of 7 degrees. Well done. Now, how do I get x? Multiply by x first, and then ultimately, yes, we're going to divide by 7. So you can just do, in your calculator, to find x, 152 over tangent of 7 degrees. And that's going to give me A, how far apart the person is from the canal, or from the lane, sorry. So, 152 divided by tangent of 7.
Okay, yeah, that's what I got.
Okay. 1237.94. Now we're dealing with centimeters. Is that right? 1237, sorry. Yeah, this thing said around 2 places, so I'm going 2 on this one for some strange reasons. Okay, now that we found the canal width, I'm supposed to find the height of the lamp pole, post, whatever. Okay, so now that I know this is 1237.94, how can I use that to my advantage?
You can put it 12 to find
This
that
guy?
side.
Yeah, so tan, again, tangent. This time it's going to be, which angle?
12.
12 equals tangent's opposite over adjacent, so what am I doing here?
What number you just got? X over the number.
X over the number I just got, right? So I'm going to take that number I just got. If you don't want to round it, that's fine until the very end. So I'm going to go right here. I'm going to multiply that number times the tangent of 12.
Thank you.
Thank you for doing that. 263.13. If you had rounded this ahead of time, so 1237.94 times the tangent of 12, you're going to get a little bit of an answer, but it's probably not going to change a whole lot. Yeah, it changes to the third decimal place. So either way, it's still going to get 263.13. But I'm not done. That was just this portion of the lamppost. So what should I do? Add it. So I'm adding that plus 152 to get what B is. So that's what, 415.13?
Yeah.
It's easy, hard? Kind of tough? Another.
So did you have to use tangent or did you use something else?
Good question. Matt asked, before we move on, if we have to use tangent. And we use tangent because, like, for our 7-degree part, we only have the piece that's opposite, and we're trying to find that. So if we use sine, we'd be finding, like, this length right here, and that wouldn't be any helpful. So that's not helpful for us trying to figure out how wide it is. If we had done cosine, you'd have to have known either this side, which we don't, or this side. So yeah, we didn't have to use tangent. Okay,
But it actually.
on number 3, we got a swimming pool, so yay for swimming pool. It says from the shallow end to the deep end, I've got a 12-degree drop. We know the pool, so if I like close off my pool right here, that's 50 feet, right? How else can I use this? Right, right. So maybe draw it kind of like this, right? So since we know it's 3 feet right here, I got a triangle here, and it says steady downward drop from the shallow end to the deep end for 12 degrees. So where the shallow end ends, for lack of a better phrase, to where the deep end ends, it's got a steady drop of 12 degrees. Okay. I want to know how deep the deep end is. So how deep is this X? Am I going to be using 3 at all?
Yes.
At the very end, right? But not right now. I want to figure out what X is. Opposite over adjacent. Which trig function is opposite over adjacent? Tangent. So tangent of 12 degrees equals opposite over adjacent. How do I get X? 5 by 50. Alright, cool, I don't know what's going on with that. Anyway, multiply 50 times tangent of 12, what do we get? 10 point, just 6? 6, 3? Yes, ma'am.
I have a quick question. Did you have to take less than probably?
No, I just found myself. That's probably why I speak at.
No, no.
Rude.
That's not what I was trying to do.
Alright. Okay, so that's how deep this part is. If I want to know how deep the total thing is, I need to add what to it? 3 feet, right? So my deep end is 13.63 feet deep, which that's fairly deep for a deep end. I think 12 or 14, somewhere around there is usually pretty standard for deep end as far as a recreational pool goes. I don't know, about like Olympic diving.
Steve, how deep is Olympic diving stuff?
22.
All right, you're gonna do number 4 real quick. Try number 4.
That's embarrassing.
Are you wearing polo?
Will you pause it?
Are you wearing anything?
No, it's not for him.
Okay, I got it. I got it. All right, here's the picture.
I got it.
That's probably roughly what it would look like. There's Penny, she got long hair. Yeah, 15 degrees goes down. All right, it should be whatever. Better? All right, cool. Anyway, we're trying to figure out how tall the statue is. So tangent is working overtime again, because I got to figure out what this distance is and what this distance is. I've cleverly labeled them x and y. So tangent of 30 degrees is equal to x over 12. Tangent of 15 degrees is equal to, so reduce again,
Y over
y over 12. So in my calculator, I'm doing 2 things. I'm multiplying 12 times the tangent of 30, 12 times the tangent of 15, and I'm adding those together. So calculator is what it look like. 12 times tangent of 30 plus 12 times the tangent of 15. So 10.14 is our answer. Questions, comments, concerns, compliments? One more. All right, on the last one, probably the most challenging of them all. All right, I got a 60-foot drawbridge. So what on my picture is 60 feet? The drawbridge, right? So that just means literally this thing is 60 feet. So the what of my triangle? The hypotenuse, right?
GTA 5.
Thanks for that comment. I said that the drawbridge is 24 feet above water, so that just means that this piece is 24 feet. We got an angle of 33 degrees. A wants us to figure out how high P is. So I want to figure out this distance, P. But then it sits above the water, so I need to add something else to it. Am I going to be doing tangent again? No. What am I going to be doing? What is it? Sine. Sine of 32 degrees equals, I don't know, over 60. If you don't know your trig stuff, you're falling more behind. So now I need to multiply to get x, multiply both sides by 60. What is it, Emma? 32.68. Okay, is that my answer? No, because I want to know how high the tip key is off of the water. So I need to add 24 to that. So 56.68. And secondly, B. When the bridge is open, what's the different distance, from Q?
Okay, well, if you draw, you can draw it down from
Possible. How I see this working is I see that this distance right here we would need is 60, right? Because that's how tall, or that's how long the bridge is. But what about this distance right here? This distance.
Oh, yeah, you can see.
Then we subtract, right? So I'm going to use cosine of 33 degrees equals x over 60. That's going to give me this value right here. So almost both sides by 60. So I have two triangles, right? I have this triangle right here. So I'm going to first figure out what x is. So I'm going to subtract from 60, yeah. Alright, so what does that give me for x? 50.32. So 60 minus that is 9.68. So that's the difference between B and Q.